The objective of this video is to learn about a function's average rate of change. The average rate of change of a function is the rate of change of the function averaged over a particular interval. This is calculated by finding the slope of the line containing the 2 points that define the interval. The line going between these 2 points is called a secant line. So the slope of the secant line is the average rate of change. The average rate of change is not constant. It changes depending on the 2 points selected. However, if the function is a linear function, then its graph is a straight line, and its average rate of change is the same thing as the slope of the line. For a straight line, the slope is constant. But for nonlinear functions, the average rate of change is not constant and depends on the points that are selected. We can see an example of this with this data set that tracks a person's height over the year since they were born. We can find the average rate of change of the function between age 13 and age 18 by calculating the slope of the secant line that passes through those 2 points. We find that the average rate of change over that interval is 3.8. This means that each year between the age of 13 and 18, the person grew an average of 3.8 inches per year. Now the important thing to realize here is it does not mean that the person grew 3.8 inches each year. It just means that on average they grew that much. So some years they may have grown a lot more, other years they may have grown a lot less. If you take the total amount grown divided by the number of years, that gives us the average per year. Another important thing to notice is that the average rate of change between age 13 and 18 is not going to be the same average rate of change between 2 other years. For example, between age 10 and 13, the average rate of change was much smaller. The person grew less per year during those years than they did between the years 13 and 18. We can see the average rate of change visually by looking at the steepness, or how fast the curve is increasing. The flatter the curve, the smaller the average rate of change. The steeper the curve, the larger the average rate of change. So we can see between ages 10 and 13, the curve is much flatter than it is between the age 13 and 18. The average rate of change is the slope of the secant line. Thus, the formula for average rate of change is the same formula that we have for the slope of a line passing through 2 points. Any of these formulas can be used to find slope or average rate of change. Notice this last one is what we've learned is called the difference quotient. In the difference quotient, instead of using 2 different x values, we use the starting x value and then define the distance between the 2 x values to be h. Thus, we're able to replace x2 with x1 plus h, and able to replace x2 minus x1 with h. Let's look at an application. When a person receives a drug injected into a muscle, the concentration of the drug in the body, measured in milligrams per 100 milliliters, is a function of the time elapsed after the injection, measured in hours. The given graph models such a situation. The independent variable x represents the number of hours after the injection, and the function value, or the y value, represents the drug's concentration. Let's practice this concept by finding the average rate of change of the drug's concentration between hours 3 and 7. We can use this formula for average rate of change and plug in the values. x1 equals 3 and x2 equals 7. Next we need to evaluate the function evaluated at 7 and the function evaluated at 3. They did not give us the equation, but they did give us the graph, so we can use that to evaluate the function at these values. Using the graph, we can see the f of 3 equals 0.05 and f of 7 equals 0.02. So let's plug those function values into our formula. Simplifying gives us negative 0.0075. We got a negative average rate of change. This indicates that the function is decreasing between the given x values. Does this make sense based on what we see in the graph? Yes. Between x equals 3 and x equals 7, the function is decreasing, which means we would expect to have a negative average rate of change. Let's identify the proper units for our average rate of change. Finding the units of average rate of change is the same thing as finding the units of slope. The units are the y units divided by the x units, or the dependent variable units divided by the independent variable units. For our example, the dependent variable units are milligrams per 100 milliliters, and the independent variable units are the number of hours. An important thing to notice when you're finding units, don't report the idea or what the type of thing is. For example, the independent variable units are not time. Time is not a unit of measurement. Time is a concept. There's various ways to measure time. So you have to specifically say what unit of measurement is being used for that concept. In this case, time is being measured in hours, so the units are hours. The unit for the average rate of change is the dependent variable units divided by the independent variable units. So we found the units for average rate of change is milligrams per 100 milliliters per hour. Next, let's explain the meaning of the average rate of change. This is similar to interpreting the meaning of slope. However, there's a few key extra phrases we have to include. So you can interpret the average rate of change as the average amount the dependent variable changes per unit change in the independent variable over the specified interval. Two important things are added compared to the meaning of slope. First, the word average amount. With slope, the dependent variable is increasing by the actual slope value. With average rate of change, the dependent variable may not actually be increasing by the average rate of change value per unit change, but the total change in the dependent variable averaged over the specified interval is increasing on average a certain amount. So the word average has to be included. Additionally, the phrase over the specified interval has to be included because the average rate of change changes depending on the interval you're referring to. For our example, we can explain the meaning of the average rate of change with something like this. Between 3 and 7 hours, the concentration of the drug decreased by an average of 0.075 milligrams per 100 milliliters each hour. Notice the main gist of the statement is describing how the dependent variable, which is the drug concentration, changed each time the independent variable increased by 1, which in this case means each hour that passes by. But notice also how I included those extra required statements, situating the time interval specified between 3 and 7 hours, and stating that it was an average decrease. Now, notice how the average rate of change was negative, but I did not include the negative sign in my statement. This is because I said decreased. If you say decrease, it indicates that it's a negative value already. Here's a brief summary of what we've learned so far about the average rate of change. The average rate of change is the slope of the secant line that passes through 2 points on the function. We can find the average rate of change using this formula. You need to focus, as you're studying, on how to find the average rate of change using the formulas we discussed, how to find the units for average rate of change, and how to interpret the meaning of average rate of change.